All right, this is a video on random samples. We need to get some definitions out of the way as always. So a simple random sample of n measurements from a population is a subset of the population selected in such a manner that every sample of size n from the population has an equal chance of being selected. A simulation is a numerical facsimile or representation of a real-world phenomenon. A sampling frame is a list of individuals from which a sample is actually selected. Undercoverage results from omitting population members from the sample frame. In other words, your sample will not represent your population well because the proportionality will be off, or we've omitted entire groups from the possibility of being picked. A sampling error is the difference between measurements from a sample and the corresponding measurements from the respective population. It is caused by the fact that the sample does not perfectly represent the population. A non-sampling error is the result of poor sample design, sloppy data collection, faulty measuring instruments, biases in questionnaires, and so on. So there's more different things out there that could be non-sampling errors. The ones that we're going to focus on for this specific set of questions is what were the sampling techniques that were used when we collected our sample? So a random sample is when you use a simple random sample from the entire population. A lot of times this is done with a random table generator where you take everyone in your sample, assign them a numbering system, and then we use the random number generator or a number table to find a starting point, and then we do sequences of those strings of numbers, and that's how we pick our sample. That one's a little more complicated to show, so we're not really going to show it, but we're going to be able to distinguish it from other types. Stratified sampling is where you divide the entire population into distinct subgroups called strata. The strata are going to be based on specific characteristics such as age, income, education level, and so on. All the members of the stratum share the specific characteristics. So if we're doing education level, everyone who has a bachelor's degree as their highest level of degree, let's say that was your strata specification, they would be in that group together. And everyone whose highest maybe degree is a master's, they would be in a group together, and all of them would have that as their highest level of education. We would then draw random samples from each stratum. So notice we're going to be breaking the people into the stratum, and then we're going to be doing that random simple sampling from each of those. Systematic sampling is where you number all the members of the population sequentially. Then from a starting point selected at random, say we're at the 17th person. After that, we will include every kth member of the population in the sample. So say for some reason the person's name we draw out of the hat was the 17th person in the line, and we've already predetermined that every 7th person is going to be picked. From number 17, we pick them, and then every 7th person after them would also get picked. Cluster sampling is very often confused by students with the stratified sampling. There's a key defining difference between them. In a cluster sampling, we divide the entire population into pre-existing segments or clusters. A lot of times these are geographic or regional or something like that. Make a random selection of clusters. So we're randomly selecting which clusters we're going to use. So that means some of the clusters may not be used. And we actually include every member of the selected cluster. Whereas when we did stratified, we put everybody in group and we sampled from every single strata. This is saying there's the clusters, which are again kind of like groups, but we're going to select different clusters randomly, and then everyone in the cluster is included. Multi-stage sampling can be a variety of things. It's a variety of sampling methods to create successfully smaller groups at each stage. Usually the final sample are consistent of clusters. And then convenient sampling is when you create a sample by using data from population members that are readily available. It's usually the least amount of work possible. So as an instructor, if I want to know about students at my college and I just talk to the students in my own classroom, I've been guilty of convenient sampling. Or if I want to know about the cafeteria food and I only go down at 11 a.m. and on a Tuesday only. So if we don't have enough variety so that everyone in the population has a chance to be picked, a lot of times we're guilty of the convenient sampling, using just what's readily available. And then we're going to look at this example. It says, what sampling technique, stratified, systematic, cluster, convenience, or random was used? I didn't include multi-stage because, again, we're looking at, can we just distinguish the separate pieces first? And then multi-stage obviously would be combinations of those. So to conduct an opinion poll on a new development project, a random sample of 10 zip codes was selected or were selected, and all households in those zip codes were called. So notice we randomly selected the groups, the zip codes. That's like a regional place that you live. Different zip codes are regional. And then all of the households in those zip codes, those 10 that we chose, are called. So that is going to be that cluster sampling. To conduct a study on boredom among housewives, a sample of 40 housewives in one neighborhood was taken. Okay, so we're assuming that these 40 housewives in this one neighborhood are going to represent all housewives and their level of boredom. That's going to be very much a convenience sample because they're not taking into effect different economic levels. Are they even going to be able to find 40 housewives in one neighborhood, first of all? So this is just very convenient. They went to one neighborhood and they knocked on doors and said, hey, are you bored? So that is a convenience sample. To maintain quality control in a factory, every 14th item coming off the production line is checked. So that's going to be that systematic. So they're going to start with a specific one, and then every 14th one after that is checked for quality. A list of student athletes were assigned numbers, and then a sample of 60 were selected using a random number table. So that is just the basic, that's supposed to say simple random sample up here. Sorry, my symbol got deleted. So this is a simple random sample. And then to determine whether or not a television show is appealing, 10,000 people were divided into age categories like 0 to 10, 11 to 20, etc. And a random selection of 10 people from each of the age categories was selected to rate the show. So they are going to include people from every single age category. So that is, we've got the stratified approach. So there are groups or strata that we've broken it into based on age, but they're going to randomly sample 10 people from each of those age categories. Okay, hopefully this was helpful for everyone.